All right. So this is kind of a response based off of a comment, and I will just say that I started getting comments, and any comment that asks questions me, and it anything that doesn't just flat out deny it. Like if you just flat out deny what I have to say, then wasted comment. Don't say anything, right? But if you want to poke a hole, if you don't understand what I'm saying and you see an issue with it, poke a hole. I want you to, because it challenges me to think about things more. And I don't right now I'm kind of in this world where it's only me that is thinking this, right? And so I'm in a what's that called? What's it called when you only look at news from one side of an echo chamber. I'm in an echo chamber that I built for myself, right? So by posting these videos, I am putting it out there, my ideas out there to the world for someone to check my work, right? And so if you see an issue, I want people to kind of say something, right? And so I've had a couple comments where they go if I'm understanding this correctly, there was one where it was saying, well, if mass is, sucking in all of this mass, wouldn't it just kind of infinitely suck in mass and keep growing? And I was like, well, yes, but no, because mass also radiates energy, right? So as it's pulling energy in, it's also sending energy out. So it's like a net zero. And if you put more energy in than you're sending out, then it starts to heat up, right? And then it starts radiating more energy, right? And so that's why high energy stuff radiates more energy, right? Is hotter. It gives off more energy because it has more energy. And so I was like, yes, right? But that wasn't one that needed me to really think about it, because I was like, I already kind of knew that answer, but it allows me to provide that response. That's something that someone didn't understand. Obviously I didn't actually explain that in that video. So, I can respond, right? And I can be like, okay, yes, they're poking holes in it, but actually that's not an issue, right? And then someone said, this one was one where I had to think about it a little bit, because I was like, does this comment really mess things up? I don't know. And so they had said, that basically it didn't work, right? It doesn't work because gravity pulls everything at equal rates, right? So, whether something is, like a light plastic ball or a heavy bowling ball, and they fall at the same rate so long as air resistance isn't accounted for, right? As long as there's no air resistance, they'll be pulled down at the same rate. And so I was like, okay, this is true. Does this ruin things? And I don't think it does, all right? And my reason why is because the argument is that something with more mass takes more energy to move it, right? And so therefore it should move slower than something with less mass, because as we know, it's a lot easier to get something moving that has less mass than something that has more mass. And because of this inertia, right, certain things should fall at different rates according to my theory, right? Because I'm saying it's a flow, and if it's a constant flow that's equal for everything, then, something should get pushed at a slower, it should be harder to push the bowling ball than it is to push the plastic ball. But there's a big difference. There's a big difference between considering trying to push the bowling ball and trying to push the plastic ball, right? Because what's the thing is that you're looking at these objects as solid. And they're not. And so it's not that the bowling ball, right, is a bowling ball and then all the dark energy is around the bowling ball. No, the dark energy is completely within the bowling ball, right? And so it's not that the dark energy is just like it's so hard to explain, but it's like it's like it's like saying that the bowling ball should get pushed less by the current of a river than the plastic ball, except both of them are made out of water, right? And so then all of a sudden it's like, what? Like, if they're both water, then like it doesn't matter what their like mass is. If they're both made out of water, then they'll just flow with the rest of the water. And yeah, that's kind of my point. It's hard to visualize that because that's not what we see. That's not observable, and it's hard to make a good example because my initial example was like, well, what if you put like a leaf and like a stick in a river? Like, which one flows faster? But I did some very rough experimentation, and I found out that it's very hard to properly test this because you need to have consistent, equal flow around both objects on all sides, right? And it's very hard to accurately model that by just chucking twigs in a stream, right? It's not very scientific. It's not very controlled. There's a lot of external influences that are messing things up, right? And those external influences are less of a big deal when, you're trying to measure the flow of water in a tube of all water, right? You don't have to worry about these inconsistencies as much because all the water is water. Again, I know that doesn't, I know that's probably not the best argument there to just say, all the water is water. But I genuinely think that is the case, is that mass is not as solid as you think it is, and therefore the inertia is not as real as you think it is. And so it's not actually harder to push anything, because the reality is that my theory is not saying, like, maybe this is a misconception that I didn't clarify well enough. My theory is not that is not necessarily that all matter is getting pulled in because the flow of dark energy is flowing by. It's more that all mass is kind of pulling in dark energy. And so from all mass's perspective, it's not moving. It is stationary. But because all of the dark matter, or the dark energy around it, because all the dark energy around it is moving, right? It is staying still from its own perspective, but there is a overall motion, right? And it's like being on the planet, right? We are on Earth, right? But Earth is moving around the sun. Relative to us, everyone is moving around the sun, right? So we're all stationary. However, we are still moving, right? We're still moving, except we don't consider ourselves to be moving. We're stationary, right? And so, similar to that, all mass is stationary, but overall, it's moving, right? And so that is why that is. And what else I wanted to say is that, okay, this is what it is. What I think, the reason why I don't think you need to worry about different masses falling down at the same rate is, okay, it's like, okay, yes, they're going to fall down at the same rate, but which one has more energy when it hits the bottom, right? If you drop a bowling ball and a plastic ball from the same height, when they hit the ground, which one has more energy, right? They may have fallen at the same speed, but they do not have the same energy. And therefore, I don't think that the rate at which they're pulled down matters, because one has more energy than the other, right? And because of that, that is what balances out this different rate of, like, they fall at the same rate, but one generates more energy during that fall than the other. And I think that is why things fall at the same rate. Somehow that just kind of works out, I guess, maybe, or not. I don't know, right? But that's my theory is that everything falls at the same rate, but not with the same energy. And so, yeah. Anyway, peace out.